All right, class. Well, welcome to statistics for the fall semester. I'm going to be remote learning from home this semester. It's going to be an interesting semester. I'm going to try my best so that it's quite seamless between an actual in-person class, um, and we'll get through it. It'll be fun too. And working from home and having a computer at home will allow us to do a lot of interesting things that we actually wouldn't be able to do in the classroom. Okay, so what I want to do today with you, first and foremost, what I want to do is I want to go through the course syllabus with you, and I want to talk about how the course is set up and structured. So let's see. Can you all see my screen right now?
Yes.
You all see the, okay, perfect. All right. So when you log into Blackboard, this is going to be our course shelf for the semester. And what I'm going to put in here is all the files, all the homeworks, all the assessments. So before class every week, you should definitely come to this part of the classroom. When you log into our Blackboard course here, there'll be a tab called Announcements. This is where you'll see all the announcements for the class. I'll also send the announcements via email to you. You'll probably get 2 to 3 announcements each week from me. And just out of curiosity, how many people in their emails got my announcements when I sent them? You could let me know if they would come. Okay, good. If you didn't get the announcements, so what I do when I send the announcements, I click an option to say send it to your email as well. I would check what email you have registered in Blackboard. And if it's not the one that you're getting your email to, you're the one you're checking, you can change that. Okay, what I first want to do today is the next tab is going through talking about your outline and overview. So if you haven't already done so, what you'll want to do after class is click this tab, and this is our course syllabus right here. And can you all see this okay? Is it big enough on your screen? Okay, great. All right, so first off, welcome to Stats. This is going to be remote learning. So we'll meet twice a week, every Tuesday and Thursday from 1 p.m. to 2:50 p.m. via Zoom. I will record the lectures, as I said, and I'll post the lectures right after class for you to review. But you should definitely try to come to class every week. I know there's a propensity because it's an online course. You're like, oh, I can watch the recordings. I find that it's kind of hard to stay motivated to do that. And it's easier to just skip through the lectures and stuff. So I really encourage you to come to class every week. I'll try to make them as interesting as possible with some cool examples. We'll do a lot of fun stuff, I think. Okay, as I said, my name is Matt Sokol. I'll be your instructor for the course. One of the first things I want to jump back to the classroom, because we're not meeting in person, there's this tab here called Discussion Board. This is optional, but I posted a welcome forum where if you wanted to post something about yourself and kind of make this class a little bit more personal, you can. I posted a bio here about myself if you're interested in reading a little bit about my background. And I just posted a picture. This is myself and my wife on the day we got engaged a number of years ago. So you could do that if you want. Okay, going back. My office location is my home office, as you can see. And my office hours are going to be held via Zoom each week. So if you look back in the classroom here, there is a tab down at the bottom called Office Hours. And if you click on that, this is the link for our office hours. The only thing I ask that you do, sometimes I won't have the link live, but I just ask that you shoot me an email and being like, hey, Matt, I want to swing by the office hours, even if it's like a 5-minute heads up, just so I know who's coming. So my official office hours are every Tuesday, 11 a.m. to 12:50, p.m., a little bit of a typo there. And Thursday, 10 a.m. to 12:50 p.m. Got a little typo, sorry. I'll also be able to take any questions you might have via email. So if you ever need to get in contact with me, My personal email or my work email is listed right here. I'll check my email multiple times a day, Monday through Friday, and I'll check it a lot on the weekends too. Probably check it 10 times on the weekends, to be honest with you. So if you shoot me an email, you will get a very quick response from me. All right, our course website is the SUNY Blackboard shell right here. Now the text for our class, we're using a free open source textbook called Introductory Statistics by OpenStax. If you click in the, oh, sorry, I didn't make that link live. My apologies. I will post a link here for our textbook in a little bit. Sorry about that. But if you just type OpenStax Statistics, this is what our textbook looks like. It's a very good read. Everything is table of contents is pretty easy for you right here. Today's lecture, we're going to be doing sections 1.1 and 1.2. I encourage you after class to just, read through the textbook. If you're interested in a hard copy of this textbook, you can order a print copy off Amazon. I think it's, you can get a paperback for 26 bucks. I think the online textbook's just fine, but if you would like the hard copy, you can do that. And sorry, I'll post that link in the classroom right after class. The other thing that you will need for this class is a TI-83 graphing calculator or a TI-84 or higher. How many people already have a TI-83 calculator? Okay, if you don't have one, you'll want to get one ASAP. I encourage you actually just to go on eBay or something and buy a used one if you don't have one. You can get a used one for like 20, 30 bucks. But we're going to use the graphing calculator a ton in this class. Probably not starting on Thursday, but starting next Tuesday, we're going to use it almost every day in class. And TI-84 is actually fine. It's perfectly fine. So what you're going to notice in this class, what I'm going to do is I'm going to show you the long way to solve problems. Like we're going to do it by hand. We'll find the mean by hand. We'll find the median by hand. We'll find the standard deviation by hand. And then what I'll do is I'll be like, okay, now that we know how to do it by hand, there's actually an easier way to do it. And we'll use your graphing calculator. And what I'll do, let me just change my screen share, is I have my own emulator here of a TI-84. So what I'll do is I will load up my TI-84 emulator and I'll say, okay, you're gonna press the stat button. You're gonna go over to calc. This is what you're gonna do. If you don't have a TI-84 and you have a TI-83, I'll also load up a TI-83 calculator too, so that you're not left out, and I'll show you how to do it with the TI-83. So I'll do both in class for you. But they're incredibly useful tools. And so you should definitely try to have that to follow along with by next Tuesday. All right, the only other requirement, obviously is Zoom access, which we all have, and a web camera. So you will need a web camera on exam days. That's the only time you'll need to turn on your camera. So what'll happen on exam days, and I'll explain when we get to that, is I just want to make sure that it's just you taking the exam on Zoom. So what you'll do is you'll load up your Zoom, you'll turn on your camera, and I'll just peruse through and make sure that no one's getting extra help, stuff like that, on the actual exam day. Okay, does anybody have any questions about that? Any of the technology requirements, things like that so far?
I do.
Sure.
So are the tests going to be uploaded through Blackboard and then we just have to log on through Zoom?
Yeah, I'll explain when we get to the exam. So you'll see in the syllabus, we have 4 exams in this class, and just a little bit of a preview. There'll be this tab here in the classroom. You can see this tab called exams. On exam day, you'll go here and you'll actually see a link to your exam. Okay, and you'll log in, and the exam will pop up on Blackboard, and you'll just have to complete it in Blackboard and submit it to me.
Okay, thank you.
Does that answer your question?
Yeah, thank you.
Yeah, no problem. No problem. Any other questions? Okay. Going back to the syllabus here. The exams are timed. Yeah, you'll have 2 hours. You'll have the exact class time to do it. So but I promise you, I've been teaching now full time. I think this is my 11th or 12th year. It's hard to remember. I think it's 12. It's hard to remember. They go so quickly. I write the exams so that a student who's really mastered the material can do them in under an hour. But then I give you 2 hours, if you're struggling a little bit or want to work some extra time. I very rarely have students have an issue of taking it within the 2-hour class period. All right. All right, going to the course description. I just want to read the first part of this course description for you. So this class is a general introduction to statistical methods for students in all academic disciplines. And that's what I love about statistics. There's so many math courses you could have taken for math credit. You could have taken an algebra course, but it's really, really hard to see the usefulness of algebra or pre-calculus in the real world. But that's not the case with statistics. So no matter what academic discipline you go into, psychology, education, political science, engineering, you're gonna need statistics. You're gonna need to know how to work with data. And that's what this class is designed to do. I didn't always used to be a teacher. I'm a little bit older than I look, I think. So before I was an educator, I worked in private industry and then for state government. And statistical knowledge is incredibly useful in the workplace. And what I hope you get out of this class is every day you'll come to class and you'll be able to see the usefulness of statistics in the real world and how it might benefit you in the future. All right, anyway, so the topics include descriptive methods in the presentation of data. We'll learn things like the mean, median, and mode, standard deviation range. We'll very briefly talk about like bar charts, histograms, things like that. Thorough treatment of the basic concepts of probability. I love teaching that section. That's one of my favorites. We'll start with like coin flip die roll examples. We'll talk about a lot of casino games. We'll talk about craps. We'll talk about roulette. I used to live in Las Vegas, so I really like that section. Then we'll move in for techniques of statistical inference and decision-making through hypothesis testing, methods of correlation and regression, and the application of non-parametric methods in various subject areas. Some of that later stuff might seem like, oh my gosh, that seems really hard, but I promise you by the end of the class, all this stuff is pretty straightforward and we'll master it. I divide the course up into 5 sections. I'm going to go into this in a little bit more detail during my course lecture. But if you scroll down in our course syllabus here, you'll see a course schedule for this class. And we're going to stick to this schedule very, very strictly. So like today, we're going to do course introduction to the basics of statistics. Next week, on Thursday, we'll do frequency and visual summary of data. And also I have listed here the corresponding textbook sections. So what you should do after class is after you listen to me lecture, what you should do is you should go and read these textbook sections, just kind of like quick overview of them, just as like a refresher to fill in the gaps. What I've also tried to build into our schedule is before every exam, I'll try to build in a review day for us, almost the entire class period. And what I'll do on the review days for this class is I'll basically have us all work a practice exam ahead of time. Okay, so that you'll be really, really well prepared for the exams, okay? There's just a few other things I wanna let you know. We have election day off this year. So we have no class on Tuesday, November 3rd. So make sure you go out and vote. And then I'm away the Tuesday before Thanksgiving. Just me, you probably have your other courses, but I won't be here. Those are 2 days just to let you know that you might not have known we have off. All right, what you're probably really interested in right now is how your grade will be determined. All right, so your grade is made up of two things, homework assignments and exams, okay? And you can see here I have the exam dates already laid out and the homework due dates already laid out, okay? So there's gonna be 7 graded homework assignments in this class. Each of these homeworks are gonna be worth 50 points. So these assignments will be posted in Blackboard at least 1 week before their due date. So your first homework assignment is actually due next Thursday, the 10th. So going back to the classroom real quickly, I have this tab called Homeworks. Probably tomorrow I'll post your first homework assignment for you there, okay? And then on Thursday, what I'll do is I'll explain to you how you submit it and answer any questions you might have on that. All right, so here are the 7 homeworks and their corresponding due dates, all right? So these homeworks are gonna be posted 2 ways, as a PDF and as a Word document, all right? So you're to download the assignment and either type your work into Word or to scan your handwritten work as a PDF file, all right? So you should submit these assignments to Blackboard in one of the following formats: a .pdf, a doc, or a JPEG. Like if you have to take pictures of it and submit it like with your phone because you don't have a scanner, you can do that. But just make sure you submit it as like a JPEG file to me. All right? Should you submit a file I can't open, I'm letting you know ahead of time. I'm just going to give you a 0 on the assignment. So like if you have a Mac, do not submit me a .pages or whatever a Mac file is. Just save it as a PDF and submit it. Okay, no late homeworks will be accepted, and I'm going to drop your lowest homework grade. Okay, so if you fail to turn in a homework assignment, that will just count as your dropped grade. So even though there are 7 homework assignments, I'm only going to count your best 6. All right, on top of that, there's going to be 4 exams in the class. Each one of these is going to be worth 100 points. These exams will be posted in Blackboard and taken during class on the following dates. They're already scheduled there and they're corresponding chapters from the textbooks. So for the exams, you'll be required to attend class via Zoom, and on those dates, you just have to have your web camera turned on. I just must not so much your work area, but I just must be allowed to see you during the exam just to make sure it's you taking it. And if you're uncomfortable with this, just please register for a different section of Math 140. Okay, so no makeup exams will be given in this class for any reason. So if you miss an exam, it's just going to count as a 0. However, I will drop your lowest exam score from exams 1 to 3. So from the first 3 exams here, you know, if you get 100, 100, and a 50, I'm just going to drop the 50. Okay, so that's great. All right, and if you just miss an exam, like you don't show up for it or something, that's just going to be your dropped exam. However, all students are required to take exam number 4, okay? And failure to take that exam number 4 on 12/17 will result in a 0 on the exam. I understand for the last exam about extenuating circumstances, but that'll be handled on a case-by-case basis. So here's how I'll handle your grades. So numerical grades will be calculated by dividing the total points earned on all assignments by the total points possible. So there's going to be 300 total points for homeworks, 300 total points for exams. You know, they're your best 2 of your first 3, and then the last exam for 600 total points. So all I'm going to do, let me just go back to this, to determine your grade. All I'm going to do, if you have, say, 500 total points in the class, I'm just going to take 500, divide it by 600. You'll have an 83, and you'll get a B in the course. All right. Here's the student learning outcomes, if you want to read through them. I just want to say one quick thing about attendance policy. I understand with everything going on, you know, you might not be able to make every class, and I will record the lectures and post them, but you really should try to make class. I won't be taking attendance to see who's here. So it's really up to you to attend. I will say this though, obviously this is the first semester I've ever taught remote, but for as long as I've been teaching this course, if you come to class every day, you pay attention, you do all the homework assignments, it's really hard to not succeed in this class, okay? Before I go back to Blackboard, does anybody have any questions about the grading structure for this class?
I have a question about the homeworks.
Sure.
So we submit it through Blackboard afterwards, or do we email them to you?
Do not email me anything. You
Okay.
submit it in Blackboard. Okay.
Okay.
What'll happen is, and I'll go over this on Thursday, because I'll have your first homework assignments uploaded on Blackboard tomorrow. It's a really easy submission process. You just save the file on your desktop or wherever you want, and then just click attach it. You'll see. It's straightforward.
Okay. Thank you.
You're welcome. Any other questions? You guys will do great. I get good vibes. I think it'll go well. All right, going back here into Blackboard just real quick. There's a tab here called Course Content. Okay, and what you'll see here, I'm just curious, did anybody log in and look at this folder already yet?
Yes.
Great, great. So every week what I'll do is I'll be lecturing via PowerPoint. So what you want to do is you'll want to download the PowerPoints, okay, and bring them to class. Or not bring them to class. Sorry, I'm a little out of it today. I have a newborn at home, so I don't sleep great, so forgive me. But let me show you what we'll do and why, if you have a printer, it's great to print them out. So what you'll notice throughout the semester, oh, thank you, Pamela. I appreciate that. He's a great kid. You guys can see my PowerPoint here. What you'll notice as we lecture here, I use the PowerPoints a lot as a guide. And a lot of times what I'll do is I will type over the PowerPoint. Okay. So you'll see me lecturing and filling in stuff. So you'll want to have these PowerPoints out ahead of time. Okay. So I have the lecture number 1 today that we're gonna cover, and then on Thursday there's another PowerPoint up there, and then I have another PowerPoint actually for Thursday that's just extra examples that we're gonna do. So I'm gonna do a lot of writing in PowerPoint. So you're gonna want to have those downloaded. Okay, let me just exit the preview. I don't want to post too far ahead in the course, but every week there's going to be, as you can see on Blackboard, I'm going to open up a folder, and inside the folder will be the PowerPoint slides for the week, okay? Additionally, after I record the lecture, I'll post it to YouTube. So I have a YouTube channel. That's just my work-related math videos. And I'll post it here, and you see the link. So like, as you can see, I taught this course earlier this morning. I recorded for an hour and 46 minutes, and the link is up there already. Okay, discussion boards. If you ever, besides the welcome forum, if you're interested in doing that, if you ever just want to post a general question, I'll check this every day. If you're more comfortable just emailing me or posting it here, you're more than welcome to do that. I will try to send out the link for every class, but there's this tab here called Online Meetings. So if you click on that, you can see here I have the Zoom meetings for all the courses, all the class meetings. So, like, oh, October 13th, you're ready to join the class, you can just click it here. So if you lose the link somewhere in your email or something, just click Online Meetings and you can join the class right there. Otherwise, there's a Student Help tab, just a lot of information out for things that you might need, counseling, stuff like that. If you want to email me through Blackboard, you can. You could click here. But if you do that, just make sure you select instructor to email me, not all users, because then the email will get sent to everybody. I actually think the easiest thing to do, though, is just type my email into whatever you use. Your grades will be posted here. When homeworks are posted, I'll post them here. And then on exam day, your exams will be posted here. And then the link here, if you want to ever come to my office hours, as I said, is right here. All right, so that's a quick overview of the class in 30 minutes. I know I went through it real quickly, but does anybody have any questions about that? No questions? All right. Everybody excited to be taking statistics? Think it'll be a good semester? Yes, thank you for that. I appreciate that. Just a few other things, let's see. If I tell a bad joke during class, I'd like to do that. If you could just give me a pity LOL in the chat, I appreciate it. Thank you, see? There you go, I appreciate that. But it'll be a fun class and we'll get through it. I know it's a stressful semester for everybody. You know, I can't speak for everybody, but I'm getting sick of being stuck in the house, but hopefully everything works out in the coming months. Okay. So what I want to do now is I'm going to turn off my video for a little bit. I'm going to leave the chat open so that if you have any questions as we start the course, you can type it in there and I will immediately see it. And I'm going to go through and start the class. Sound good to everybody? Just a quick heads up, just so you know the course structure here. So what'll happen is I will lecture every day. When we meet every Tuesday, Thursday, I'll lecture for about an hour straight, or maybe 50 minutes, maybe 55 minutes. And then we'll stop and take at least a 5-minute break. So we'll take a 5-minute break in about 15, 20 minutes. It's just as a way to break this up so that you can get up and walk around. I'll need to refill my coffee, stuff like that. All right, everybody? Okay. All right, so welcome to statistics. And what I want to do now is before we get into like learning a lot of new material, I want to talk about what statistics is and in a little bit more detail, the topics of the class. All right, so what is statistics, right? And statistics, according to our textbook, is the study of the collection, analysis, interpretation, presentation, and organization of data. Oops, so what statistics is here? Statistics is all about data. Okay, what does data tell us? And what can we conclude from it? And if you think about it, we live in a world where you're bombarded with data every day. I mean, if you just look at some of these graphs here, right? Like, or even some of the formulas here, you're used to seeing all this stuff in the real world, and we're going to dig deeper into the understanding of it and some of its great applications. So why study statistics, right? There's like a ton of other courses you could take. I kid you not, for as long as I've been teaching, I love this course. I just think it's so much fun and it's so applicable to the real world. First thing, data is everywhere. You want to become an informed consumer of numerical information, okay? You can't go through the day without seeing data. Like you can't open up a newspaper and not see a bar chart. You can't turn on the nightly news. It's an election year. You can't turn on the nightly news and not see some type of information about or statistic about polling or approval ratings or what percentage of people is going to vote for who. Secondly, statistical decisions matter. Statistical techniques are used to make decisions that affect our daily lives. That is, they affect our personal welfare. Here's a perfect example of how important statistical processes are. Has anybody been paying attention to the news about possible vaccines that might be coming out for COVID? think they said that, yeah, there's like, I think, thanks for everybody posting the forums there, or the chat. Yeah, it seems like there's like 3 vaccines and yeah, you can raise your hand. Do you have a question? Nope. Okay. So it seems like you can't, I don't watch the news. You're probably smart for doing that better. Um, but anyways, so these so MDs and PhDs and scientists and doctors are going to develop a vaccine, and then they're going to go into this thing called clinical trials. Like that's the big news right now. Well, what they do is once they have a vaccine, they give it to statisticians or what are called biostatisticians, and they use statistical methods to determine the effectiveness of vaccines. So like the processes that we eventually talk about in this class are going to be used so that we can all go back to the classroom and see each other in person. And finally, this class has a ton of value. So no matter what field of study you go into or career you take, you'll make use of statistics. So I think I said this, in the workplace, statistical methods are incredibly valuable. You know, my first job out of graduate school was working as a mathematician. So obviously I used a lot of math there, but then I moved into policy and state government. And I talked and used statistics every day, and having these skill sets put me above my coworkers because a lot of them didn't. Okay, so this course, if you look back in the syllabus, is divided into 5 sections of study, each incredibly important, and each one builds on each other. So what I want to do before our break is just kind of go through all the sections in a little bit of detail. Okay, so section 1 is going to be an introduction, sampling, data types, graphical, and numerical summary of data. So this one here we'll spend about 2 weeks in. This is going to be a lot of number crunching. All right, I'll be honest with you ahead of time. It's also the most dry section of the class. A lot of this is, hey, here's a formula, here's how you apply the formula, here's a chart, here's how you make the chart. So just realize as we go through the first couple of weeks, it might not seem that interesting, but the course gets a little bit harder and much more theory-based as we go forward. The second topic is called correlation and regression. We'll spend about 1.5 weeks here. All right. These 2 topics are really a lot of fun, and especially in this section here, you're going to need your graphing calculator because the formulas get really crazy, and the use of technology makes this section a lot easier. All right, next we'll talk about, in section 3 is talking about probability and discrete random variables. We'll spend another couple weeks here in this section here. I love teaching this section, specifically probability. I used to live in Las Vegas, so just the applications of probability, especially as it relates to casino games, is just really, really fun to talk about. Section 4, we talk about continuous random variables, the normal distribution and sampling distribution. This section here begins like the advanced study of statistics. We'll learn how to read statistical tables, and we'll start to see how you can draw, just the beginnings of how you draw conclusions from data. And then our final section of the class, section 5, it's about statistical inference. And in this section here, we're going to study 2 main topics, hypothesis testing and confidence intervals. These right here will be the most useful 2 topics as you go on, and if you go on to graduate school or further study in statistics. Okay, so let me just go into a little bit more detail about each section here. So section 1, all right, in this, we will first learn the process of statistics. That's what we're going to learn about today, and how to classify different data types. So this is today's lecture. All right, and then we're going to learn methods for graphical methods for summarizing data, numerical methods for summarizing data. This right here is going to be Thursday and then next week. And a lot of this stuff you guys have all heard of before. Like, how many people have heard of the mean, median, mode before? Mean, median, and mode. Like when I say the median of a data set, okay? The median. What does the median mean? Yeah, Joanna's got it. It's the middle. How about the mode? The mode. What is the mode? Yep, you guys are right. The one that appears the most. So we'll learn a lot of this stuff you might have seen before, things like bar charts, histogram, pie charts. We'll talk really, really briefly about. But then we'll learn maybe it's about some things that you haven't heard before. Maybe like you've heard of the concept of a standard deviation, but what exactly is a standard deviation? We'll learn. I'll show you how to calculate that, what it means. We'll learn about things like the interquartile range, stuff like that. All right, as I said, honestly, this is the most dry section, but we'll get through it pretty quickly. So this section here is what we call descriptive statistics, right? This section 1, and these are methods for organizing and summarizing information. So this includes graphs, charts, tables, descriptive measures such as averages, measures of variation, and percentiles. What this section is about taking data and turning it into information. Okay, taking raw data and turning it into some type of consumable information. Like I have this crazy data set, well, what's the average of it? What is the distribution? What does the histogram look like? That's what descriptive statistics are about. All right, our second section of the class is we talk about the relationship or how two variables are related. So here's the example I'd like to give. About 3 years ago, I had a big life event. I purchased my first home. You know, if you guys want to say congrats in the chat box or anything like that. No, it's too late. You guys should have been on that quicker. All right, but let me give you an example about what the relationship between these two. Do you guys think how much a home sells for and its square feet are related? So sale price and the square feet. Yeah, I agree. Now, my question for you is what type of relationship is this? Yeah, I agree. It looks like it's a positive relationship. What I mean by that is the larger the square footage, the more a house is going to sell for, right? That's kind of the correlation you're talking about here. So there's two topics to cover in this section. Correlation here, and what correlation is going to measure, it's going to measure the strength of that relationship, okay? Like how strong is the relationship between square footage and sale price, you know? Like, I think there is a relationship between the number of bathrooms in a home and its sale price, but is that relationship strength, you know, the same as square footage? Maybe, maybe not. Then after we talk about correlation, we're going to move into linear regression. And what this talks about is how you model the relationship. Okay, so linear regression will model it. Correlation measures strength. This is a fun section. And as I said before, in this section, we'll make heavy use of our calculator. And I'll also show you a little bit how to use Microsoft Excel in this course, and we'll use that a little bit in here too. So our third section is going to be the basics of probability. So we're going to start easy. We're going to talk a lot about things like coin flips and die rolls. And the reason we start with these concepts is they're easy to understand, and they also are a good way to set up the harder concepts. So like, here's the first question we'll actually do in this class, okay, for probability. Suppose you flip a coin 3 times in a row. okay? You're gonna flip a coin 3 times in a row. Can anybody in the chat box tell me what they think the probability that you're gonna get heads 3 times in a row is? You're gonna 50, 50. Anybody else got a different? So you're gonna flip a coin 3 times in a row and you wanna get heads 3 times in a row. Anybody got a different answer? No? Maybe, it depends what you got 15 rounded as. So it's actually, I'll stop you guys here. It's actually a little bit harder than you think, all right? So the probability, and you'll see this in the coming weeks, but the probability you flip heads 3 times in a row and get head, 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 it's not 50%, okay? It's not 40, it's not 15, it's not 20. It's a little bit, even though it seems like, oh, this is easy flipping coins, the answer you guys will see in the coming weeks, it's actually 1 out of 8, and I'll show you how to do that. Then we'll work towards harder stuff. You know, like one of the last problems we'll do actually is the probability you win the Powerball lottery with a single ticket. And it's actually, that one's a little hard to set up. But after, you know, we'll build to it. I'll give you a preview. The answer is it's very small odds that happens. But that'll be fun working towards that too. All right, then the next topic we talk about here is we learn about what a random variable is in statistics. So in mathematics, what letter do you generally let represent a variable? Yeah, it's gonna be a little bit different in statistics, okay? You know, generally you let X be some unknown value. Here we're going to tie this unknown value to a probability distribution. So that's what we're going to talk about here. All right, we'll also talk about things called expected values. And then the last thing in this section we'll talk about is a very complicated probability distribution called the binomial probability distribution. And you can see we'll learn this crazy formula here. And actually it looks really hard maybe right now, or maybe it doesn't look hard. But I'll show you how to handle this very easily, and then we'll also use our calculator a lot to do this. All right, the fourth section of the course, we'll continue our study of that concept of random variables, but here we're going to learn about a lot of different probability distributions. First one we'll learn about is something called the uniform distribution. Then we'll learn about something called the normal distribution. And you might have heard of this called, has anyone heard of the bell curve before? If you haven't or you have, that's okay. This concept right here, this normal distribution, we're going to spend the most time on this. Sorry, a little bit of typing issue here. We're going to spend the most time here. There is a lot of great applications to the bell curve, and it's a naturally occurring distribution, and there's a lot of statistical properties to it. Then we're going to learn about something called sampling distributions, and this is really where we begin the advanced theory of statistics, theory or study. And here's the basic concept of sampling distributions. Suppose, you know, gosh, there's probably 500 Zoom classes going on today for WCC, okay? If we take the average height in our classroom and compare it to the average height in another Zoom classroom, do you guys think those averages, like the average height in our classroom compared to an average height in a different statistics course, will be the same? Do you think average? Yeah, absolutely not. There's no way they'll be the same. But what we'll do is we'll notice that if I look at the average height in this classroom compared to the average height in this classroom, across all the classrooms at WCC, when I say classrooms, I mean Zoom classrooms, obviously, we're going to notice something very, very cool happens. And this right here is a preview of that. okay? And this is going to be kind of like the beginning of our, as I said, advanced theory and the foundations for statistical inference that we learn in the final section. Okay, the final section, section 5, we'll learn how to form conclusions from data. So there's two main topics: confidence intervals and hypothesis testing. So confidence intervals you've all seen before, actually. I know some people in here said they don't really watch the news too much, but has anybody, I'll talk about this a little in this class, and I'll bring this topic up, but I never want to talk politics in this course. But has anybody paid attention to any of the political polls that have been going on in the news? You know, you might see something like the president's approval rating is something like, I don't know, I'm just making this up, 40%. I don't pay too much attention to it. But if you've seen something like this, if you look down in the bottom of these polls, they'll always say something like, the margin of error is something like plus or minus 3%. Okay, that margin of error, that's just not some made up number. That's actually something called a confidence interval. And I'm gonna show you how to construct that margin of error. We will actually take political polls that are on the news and reconstruct them so that you can see how they're made, okay? Hypothesis testing is our last topic then. And what this topic is about is how you, going back a little, test the validity of a claim. Okay, a little bit more detail on that, but what I mean by the validity of a claim, does anybody, I'm just out of curiosity, in the forums, know on average, how much TV per week adult Americans watch? How many hours per week do you think on average adults watch per week in the United States? Anybody, I don't know, just throw out a number of hours per week. Does anybody got a guess? A ton? You're not wrong. It's actually, so people watch more TV than they realize. 6 hours a week, I wish. 15 through 25, not bad, 15, okay. 50, that's a full-time job. Yeah, that would be tough. All right, so actually, believe it or not, adult Americans watch about 30 hours per week on average of television, okay? Is anybody surprised by that number, that on average adults watch 30 hours of TV a week? All right, so I'm gonna make a claim now, okay? And you guys tell me what you think about this claim. Do you think WCC students, okay, college students, WCC students watch less TV on average than the general population? You guys don't think you watch less TV on average? I absolutely think you do. You guys aren't giving yourself enough credit. I think college students got a lot going on. It includes Netflix, yeah. I mean, television watching is things like that. Well, so remember, this is on average. So some students will watch a lot, some won't. So I made a claim. So I'm making a claim. I think that students watch less on average. So that claim can either be true or false. So what we want to do is test the validity of that claim. And that's what I'm going to show you in hypothesis testing. All right, this last section, section 5, is called inferential statistics, and it's methods for drawing and measuring the reliability of conclusions about a population based on information obtained from a sample. So what inferential statistics does is different than descriptive. Descriptive takes data and turns it into information. Inferential statistics takes data and turns it into knowledge, okay? What we're going to talk about is how statisticians analyze information obtained from a sample of the voting population to make inferences or draw conclusions about the preferences of an entire population. So what this is going to be about is how we use what's called a sample, and I'll define that in a little bit, to say something about an entire population. And this will be our last topic, and it's I think it's one of the more fun topics because it's you dig deep into data. Okay, so what we're going to do now is I've been going on for about 54 minutes. Okay, so what we're going to do here is we're going to take a 5-minute break. Does that sound okay for everybody? So it's 1:55 now. So what we'll do is we'll take a break for 5 minutes. And then we'll come back up and pick up with some of the more advanced stuff, okay? So I'm gonna turn my mic off. I'm gonna go refill my coffee. Before I go, does anybody have any questions before we take our break? All right, everybody, I'll see you in 5 minutes, okay? All right, everybody. I know that was a quick 5-minute break. Can everybody hear me? My mic is back working just fine. Okay. Generally what I'll try to do, I just got a lot I got to cover in the second half of class. Generally what I'll try to do is going forward, I'll try to get it so we can have a 10-minute break in between to just break this up a little bit. But just for today, we'll just cut it a little short, okay? All right, so we spent the first hour of class kind of just talking about, the course structure and, what topics we're going to cover, things like that. So I hope everyone's a little excited to be taking statistics. What do you guys think? Excited, not excited? Oh, thank you. Thank you for that in the forums. Everybody who posted, A's, everybody who didn't F's. Okay, that was a joke. You don't have to post. But I hope you are. It's going to be some interesting stuff. And thank you for the pity LOLs. I appreciate that. Okay, so what I want to talk about in the second half of class is first something called the process of statistics. Now, this is just a general process that in the real world, how you can use statistics to draw conclusions. Okay. And then after that, I want to talk about data types. And then finally, I'm going to talk about sampling methods. Okay. So the process of statistics, okay, this is a 5-step process that you can take and apply the concepts you learn in the class to the real world. So the first step in the process of statistics is ask a research question, okay? So here, this is going to be what's called a hypothesis, or it's kind of that claim I made, okay? So when you ask a research question or you have a hypothesis, you make a claim, what you ultimately want to do is you want to test the validity of that claim, okay? That we want to get to that section number 5, that statistical inference. To do that, what you're going to have to do is you're going to have to design a study and you're going to have to collect data, okay? So what you're going to have to do is you're going to have to sample from a population. And I'll explain more in a little bit what a difference between a sample and a population is. For this class, these 2 sections here, steps, step 1 and step 2, generally I'll come to class, I'll say, okay, hey, here's our research question and here's the data for us. So I'll do that for you in this class. But as you go further in your academic career, especially if you go to graduate school, this is what you're going to spend a lot of time doing, not necessarily in this intro stats course. The third step is what you're going to have to do is once you've collected your data here, you're going to have to explore the data. This is section number 1 of our course. Okay, this is that turning data into information. All right, this is, we're going to take our raw data set and find the mean, the median, maybe look at a bar chart of it. Just turn the raw information or raw data into consumable information. After that, the next thing you're going to have to do is you're going to draw inferences and formulate conclusions. So this right here is section number 5 of our course. Okay, so we're going to go from here to here. And I know you're probably thinking, well, what about sections number 2, 3, and 4? Well, to go from 1 to 5, you need to have a good understanding of the previous sections. Like they all build on each other. Okay, but this right here, this is our course. This is what we're going to spend 15 weeks talking about, how you explore data, and then eventually how you draw conclusions from data. One thing we'll do a little bit in this class, we'll even do it a little bit today, but a real important step in the process of statistics is a reflection and looking back. And what this is can your study be improved? Or what are the issues with the study? And what I actually want to do now is I want to walk you through an actual statistical study and show you the 5 steps in action, okay? And I'm going to put up a poll right now, and I would like everybody to participate in this. Now, your results are anonymous, so just answer truthfully, okay? That's the most important thing. And the first, our question's actually going to be about, it's a little bit of a macabre example, but it's about organ donation. So my question for you, all the people who are here, is being an organ donor a good thing? Okay, so just answer honestly. Do you think people being an organ donor is a good thing for society? And I'll give you a minute so people can answer the question. Answer the poll. You don't have to post in the chat form. Answer the poll here. You don't have to answer yes, by the way. Okay, this isn't just, just want you to answer honestly. I'm going to give you another 20 seconds or so to answer this poll, and then I'm going to show you the results. All right, I'm going to end it in a second here. So here are the results, okay? So you can see, so this is what percentage of people think being an organ donor is a good thing. All right, so it looks like 88% of our class here think being an organ donor is a good thing, okay? You guys can all see the results right there. All right, so look, the whole point of this is yes, a large percentage of people think being an organ donor is a good thing. Okay, but now I have a question for you all, and please answer honestly. All right, we think being an organ donor is a good thing, but here's a question. Are you actually an organ donor? Okay. Does anybody know how you become an organ donor? You can type in the chat box. Pamela has it. You sign up to being an organ donor through the DMV. Okay, I'll give you another couple seconds here. So remember, 88% of you said being an organ donor is a good thing. All right, I'm going to stop the poll now. This is what percentage of you are actually organ donors, okay? So look at that. Is anybody surprised by that result? It's weird though, right? I mean, it's weird, right? Almost 90% of you said being an organ donor is a good thing, but over 70% of you are not organ donors. Okay, so let me walk through a study that tackles why we see that, okay? So even though organ donation saves lives, okay, recruiting organ donors is really difficult, as we just saw, okay? Surveys say that about 95% of Americans approve of organ donation in principle, and many states have a simple organ donation registration process that you guys were right. I think Pamela said this, that you apply through your driver's license. However, only 54% nationally of licensed drivers in the United States are registered to be organ donors, okay? I'm just curious. Is anybody in the class not from New York or not taking the class from New York? So the reason I asked that is I actually live in New Jersey. Okay, I'm originally from New York. So the way you become an organ donor in New York State is you apply when you go to get your driver's license. There's just a question on there that says, would you like to be an organ donor? Okay, that's the question. Now, what do you think most people do when they see that question on their driver's license application? You can write no, but let me ask you this. Can you just skip the question? Yeah, that's it. A lot of people can just skip it, okay? Part of the reason is in the next sentence here, some people prefer not to make an active decision about organ donation, okay? Because it's an unpleasant topic. So what do you have to think about when you have to think about organ donation? You have to think about your what? Yeah, you have to think about your, and that's an unpleasant thing to think about. So actually in New York State, a lot of people just skip the question. So in New York, what do you think happens if you skip the organ donation question? Do you think they make you an organ donor or you're not an organ donor? Yeah, yeah, that's the thing. So New York State has this default no question. Okay. New Jersey is a little different. So I grew up in Albany, New York, but I met a Jersey girl. So I live in New Jersey now. Not a bad thing. Jersey gets a bad rep, but they actually don't even call it the DMV. They call it the MVC. They call it the Motor Vehicle Commission here. But anyways, when I was going to get my license in New Jersey, I was talking to the person doing my paperwork, and she says to me, she goes, "Okay, sir, please answer this question." Okay. And it popped up and said, "Would you like to be an organ donor? Yes or no?" Okay. And I had to answer. Okay. So they said, had to pick. Okay. So interestingly, only about 30% of people in New York choose to be organ donors. Do you think New Jersey is better or worse than New York? Worse. I hate to say this, guys, but my new state is better. About 40% of people in New Jersey choose to be organ donors in New Jersey. I'm just curious. Does anybody have a guess what state has the highest rate of people choosing to be organ donors? It's not California. Anybody got another guess? It's not Texas. Nope, not Texas. It's not Vermont. That's a good guess, but it's not Vermont. Vermont's up there, but it's not Vermont. It's not Washington. I've actually never had a student guess this. Delaware, South Carolina, nope. Connecticut, nope. It's not New York, nope, obviously. It's not Florida. Oh, Wyoming's close. I'll stop you. It's Montana. Montana's close to 95% of people choose to be organ donors. Okay. I don't know why. I couldn't tell you how they do their driver's license. But there's something about Montana that has a large percentage of people who choose to be organ donors. Okay. All right. So here's what we're seeing. Okay. New York and New Jersey choose or recruit organ donors differently. Okay. So here's a hypothesis. So going back for the process of statistics, we're going to ask a research question. Okay. And here's the research question. Could phrasing the question differently affect people's willingness to become an organ donor? Okay, so my question for you is this. Do you think it's how it's presented to people on their driver's license could impact people who choose to be organ donors? What do you think, yes or no? Okay, so here's the thing, it's a claim. So what we need to do now is test the validity of the claim. So we need to do this process of statistics, okay? All right, so this is going to simple exercise be our first look at the process or how we solve problems in this course. So this is going to actually follow an actual study. So the link is here. So it's a study from Columbia University in New York City, okay? So here's the study. All right, so what these professors at Columbia University did was they recruited Columbia University students. They put out these flyers and they said, look, I want you to be part of this study. So got students to be part of study. And they didn't tell the students what the study was, okay? They just said, hey, you have to come, you show up, and then you'll be part of the study. So all these students went into it not knowing what it was. And then what happened is when the students showed up, they had the students fill out driver's license applications, okay? And it looked like a normal driver's license application. Where do you live, your height, your age, your birth date, your weight, your eye color, everything like that. And then there was a section on being an organ donor, okay? And what happened was is they put the students into 3 different groups here, okay? And so some students were assigned a group, were forced to make a choice of being an organ donor or not without being given a default choice. So this was they had to pick. Okay, this is how New Jersey does it. Okay, the great state of New Jersey, the Garden State. All right, other participants on their driver's license application said they were told the default option was not to be an organ donor, but they could choose to be an organ donor if they wished. Okay, so they could opt in. This is how you guys do it in New York State, okay? Then the remaining participants were told that the default option was to just be an organ donor. Okay, hey, look, you're already an organ donor, all right, just by being in our state, but you could choose not to be. Okay, so this is the opt-out group. Unfortunately, I don't know a state that does this, okay? So forgive me, I don't have a state for that. Okay, I tried looking on the internet, but I couldn't find driver's license applications for all 50 states. Okay, so here's my question. I have 3 groups here. Do you think any of these groups are more likely to have people be organ donors than the others? So like maybe in the chat, what group do you think would be the best at being an organ donor? Number 1, where people actually had to choose. Okay, all right, not a bad guess. Number 3, that's a good one too. Yeah, okay. Which one do you think will be the lowest? Yeah, maybe. I don't know. Okay, so this is what we have to find out. All right, so here's the 5-step process in action with this actual study, okay? So ask a research question. 1, does the default option presented to driver's license applicants influence the likelihood of someone becoming an organ donor? So this is our research question. And the answer to this is going to be yes or no, okay? And you need evidence to make a conclusion here, okay? So that's step 1, okay? Ask a research question. Step 2, if you look back, design a study and collect data. That's what they did. They recruited the various participants and asked them to pretend to apply for a new driver's license, randomly assign them to groups. Great. Step 3, this is where you explore the data. All right, so what I want to show you is what they did and how they summarized the data, okay? So what I have here is the results of the study, okay? Here are your 3 groups. This is the opt-in group. This is the New York group. This is the opt-out group. Remember, I don't know exactly how many people or what states did that. And this was the neutral group, like New Jersey. And what this chart is called it's called a cumulative frequency bar chart. And what you see up here is this represents 100% of the people in the group. And looking right here, these are the proportion of people who chose not to be a donor in this first group and the proportion of people who chose to be a donor in this group. And if you look down here, it tells you the proportion of people who chose to be donors. It was roughly 42% here chose to be a donor. The opt-out people where you default, they're like, hey, you have to be an organ donor, but you can choose not to be. It looked like roughly 82% of people here chose to be a donor. And in New Jersey, okay, where they forced people to choose based on this experiment, looked like it was roughly 79% of people chose to be a donor. Okay, looking at this, are 2 groups better than another? Like my question for this is, which state does it look like does the worst job at recruiting organ donors right now? Yeah. All right, you guys in New York, I'm not judging you from afar, from New Jersey, but I am kind of. You guys are doing the worst job at recruiting organ donors, all right? I want to talk about this. Thank you for the pity LOLs, okay? This is how New Jersey does this, okay? And what we're saying is based on this experiment, 79% of people chose to be organ donors, okay? Do you guys remember what I said roughly in the real world? People in New Jersey, what percentage of people in New Jersey are organ donors? That was New York. It was roughly 40%. Okay, but so look at the difference here. The experiment's saying we should recruit almost 80%, but in the real world, it's only 40%. Okay, so I want to come back to that in a little bit. All right, going back here. All right, when you look at the results, what do you think? Does evidence support something? Like, what's your conclusion here? Does the default option based on this experiment influence people's likelihood? Yes or no? Absolutely. Yes, just looking at this experiment, yes, our conclusion is yes, it does. It's like perfect, great. You know, this, we should all switch to either the New Jersey method or the default yes method, okay? So this is kind of how we use data to draw conclusions, all right? But this step right here is really, really important, okay? What do we think of this study, and are there any limitations to it? So there's two main issues with this study, okay? And I'm just gonna tell you what the issues are, and we'll see about it. The first one here, for a little help on this, who exactly did they recruit to be part of this study? Who are the only people they asked to be in the study? Yeah, college students, but even be more specific, college students from where? Only Columbia U students. Yeah, the only people that were part of the study was Columbia University students. So what that means is our results can only be applied to Columbia students. I'm just going to put CU students. So really what we're saying here is, does the default option presented to driver's license applicants at Columbia U influence their likelihood? Yes. So you really can't take this result and apply it to the general population, okay? Because our sample, the students we only talked to or sampled in it, are only from Columbia University. So that's a big issue. Then the final issue is what's called response bias. Okay, and what response bias is a big issue with these experiments. So like when I go fill out a driver's license application as part of this study, and I get to the question about organ donation, I know someone's gonna read my result, and then what I presume they're gonna do is they're gonna judge me, okay? So they're gonna say, oh, Matt didn't wanna be an organ donor. He must not be a nice person. So I'm gonna give the response I think they want me to give, when in reality, I would never be an organ donor. Okay, does that make sense? Like I'd give the result people want to hear because it has no bearing on my real world. So this is an issue, response bias. So these are two huge issues with this study, okay? For the record, I am a organ donor, but these are two huge issues with the study, and why, you know, it's really important to just be careful what conclusions you draw from data. So it's really important when you see a statistical study to step back and say, okay, what conclusions are they making and what can we really conclude from? All right, kind of an interesting example. I think it is. I hope you guys think it's an interesting example. So we'll do stuff like this in class. We'll look at data like this and studies like this a lot in the coming weeks. Okay, so what I want to do now, we got 25 minutes left of class. I really just want to burn through some definitions, okay? All right, so now what I want to talk about first is the difference between a population and a sample. And these are some key definitions. And these definitions are incredibly important for the rest of the class because they're going to come up all the time. Okay, so the difference between a population and a sample. A population is a collection of all items of interest or under investigation. What I like to think of a population is, it's a data set that has all possible values. Okay, this population has all the possible values, all the possible data values. We let the capital letter N, this is a subtle difference, but really important between what you see down here. Capital N represents the population size, okay? So capital N, population. And I have an example in a little bit of this, okay? In the real world, a lot of times it's really hard to have a population data set. So what we do is we take what's called a sample. And a sample is an observed subset of the population. So it's a small subset of data taken from a population. And the subtle difference here you see here is we let lowercase n represent the sample size. So lowercase n, sample size. So I know it seems like I'm beating a dead horse here, but capital N is the population size, lowercase n is the sample size, right? And you can think of data can be thought of as values measured or categories recorded on individual entities of interest in our data set. From that, we have these two values that we're going to be talking about a lot in this class. The difference between a parameter and a statistic. And this course is called statistics, so obviously we're going to talk more about a statistic. So a parameter is a specific characteristic of a population. So think about a parameter. Our values calculated from a population. Going forward, generally parameters are going to get Greek letters. They're going to be denoted with Greek letters. All right, the three most common parameters we're going to see in this class, we're going to use this Greek letter that looks like a U. Okay, that's the Greek letter mu. We're going to use this Greek letter. It looks like a sad 6, okay, but it's the Greek letter sigma. And then the non-Greek letter we'll use for a parameter is the value p. This is going to stand for a proportion. And a statistic then is a specific characteristic of a sample, okay? So a statistic is going to be values calculated from a sample. And they're going to get different notations. They're going to be things like X bar, S, P with a little hat above it that's actually going to be called P hat, but I'll define all these going forward. So when you see stuff like this in this course, these are going to be parameters. These are going to be statistics. Parameters come from a population. Statistics come from a sample. Now, let me give you some examples of this real quick so you can kind of understand the difference. So this is a silly example, okay? So suppose the letters of the alphabet, okay, are paid a salary based on how much they're used, okay? So imagine the letters are like real beings and they're paid a salary, okay? So like A makes a lot of money and Z doesn't make a lot of money, okay? Values calculated from this, so like the average salary of all these letters here, all right, when you have all the letters in the alphabet, the English alphabet, which is 26, this would be a parameter. Okay, but suppose you took a small sample, okay, of this 1, 2, 3, 4, 5, 6, 7, 8, 9 letters, and you calculated the average salary of these 9 letters, that would be a statistic. Okay, so parameters come from complete information and statistics come from a sample or a subset of the population. Right? Does that kind of make a little sense? The subtle difference there? Okay, here's just another visualization of this, all right? Imagine these dots represent individuals, okay? Any value calculated from an entire population, again, that's a parameter. But if you were to just take these 4 individuals from this entire population, any value calculated from this small sample, this would be a statistic, okay? Let me give you an actual real world example of this, okay? And a common way that you can see the subtle difference between these parameters here and these statistics is in survey research and polling, okay? So political polls or polls in general provide an example of what we call this inferential statistic. So interviewing everyone at voting age in the United States on their voting preferences is expensive and unrealistic, okay? You know, when you see a political poll that says something like 40% of people support the president, you know, they didn't call me, they probably didn't call you, but they're saying something about the entire population. So statisticians who want to gauge the sentiment of an entire population of US voters can afford to interview only a carefully chosen group of a few thousand voters. And this is called that sample of a population. So what we do is we use a sample and statistics to estimate for a population and parameters. So here's an example. I'll talk about my wife and my family a little bit in this class because, you know, I don't know, why not? But my wife works at this place called the Rutgers Eagleton Poll. My wife's actually a survey researcher, a pollster. And so she put out a poll recently about the pandemic. And it said something like 2/3 of New Jerseyans feel the state is moving at the right pace to reopen, okay? So let me ask you this. Do you think my wife called every single New Jerseyan to get this poll? No, she obviously didn't, okay? And if you're interested, you can read the press release here about it, but let me show you just the important information about it, okay? So what she did was she took a sample, okay? And the results are from a statewide poll of 1,502 adults. So that right there is our sample size, okay? That's where the lowercase n comes in. All right, and this was, you know, by live callers on landlines and cells. From here, you can see that. So when she said something like 2/3 of New Jerseyans, okay, this is a statistic. And it's okay to use this to say something about the entire population. So we are drawing a conclusion, and it's okay to actually do this. And we'll see this in the advanced theory of the class later on, to say that about all people who live in New Jersey. And even though we only you only use 1,500 people, it's okay to extrapolate that for all 8.8 million people who live in New Jersey. And that's the subtle difference between the lowercase n and the capital N, okay? So this was a statistic, and we're using statistics to say something about an entire population. All right, before I move on, kind of makes sense where we're going with this? I hope so. Okay. Good. All right. Next, I've been talking a lot about data, and I want to talk really briefly about is how you classify data, okay? So data has different types of classifications or how we call it or what we call it by, okay? So not every data point is the same. So data on someone's height, how tall someone is different from data on their hair color or their eye color. Okay, these are two different types of data classifications. So the first way we classify data is by one of two ways. We can either have what's called a qualitative data value, or we can have what's called a quantitative data value. Okay, qualitative data values are what we call categorical, allow for classification of individuals based on some attribute or characteristic that they have. okay? So let me give you an example of an attribute or characteristic that I could assign to everybody, okay? We can assign people by their sex, right? They're either male or they're female. We can classify people by their grade level. You know, you're either a freshman or you're a sophomore at the community college. Okay, these are the categories you fit into. So that's qualitative. Okay, so data first. You either have to decide if it's qualitative or data can then be quantitative. Right? Quantitative provide numerical measures of individuals. Okay, numerical measures of individuals are things like how tall people are, right? An individual's height. It can also be things like the number of cups of coffee they drink per day. I'll answer that question in 1 second. So for today's class, to answer your question, Joanna, for today's class, what I'm going to do, because I don't know if people have had a chance to write this all down, is I'm going to save this PDF or this PowerPoint and post it for you with all my write-ups. But going forward, I'm not going to do that. So it's a way for you to come to class and like kind of take notes as I'm going. And it's also a way to help keep you engaged by writing the notes down. Does that make sense?
Yes.
Okay. So quantitative variables are qualitative categories you fit into, quantitative numerical measures, okay? So let me give you some examples of this. Here are some examples of qualitative, things like your eye color, your smoking status, your attitude toward the death penalty. You fit into one of these categories, okay? Or groups, all right? In this class, I will only test you on if you can identify if it's qualitative or not. But if you're interested, you can read the textbook. You can actually classify qualitative variables next as either ordinal or nominal, but I'll leave that to you on your own. Here are some examples of quantitative, okay? Things like your pulse rate, your height, your age, exam marks. These are all like numerical measures, numerical values. Size of a bicycle frame, time to complete a statistic test, number of cigarettes smoked in a day, all numerical values. Turns out though that quantitative variables, right, how you identify the time it takes a test and the number of cigarettes smoked in a day can actually be a little bit more granular, okay? So quantitative data can then be broken up as either discrete data or continuous data, okay? So a discrete data value or discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. I like to think of discrete variables as counts of some type. Continuous variable, right? This is a quantitative variable that has an infinite number of possible values that is not countable. Continuous variables tend to be measurements on individuals. Okay, so the difference between counts and measurements. So here are some examples of discrete. Number of children in a family, like I have, here's another way you can figure out if it's discrete. I have one child, I have a son, child number 1. If I have another child, that would be my what child? Not my first child, but he or she would be my, yeah. So it's like you know the next possible value. That's what discrete is. Number of students passing exams, number of crimes reported, number of bicycles sold. You know, all these are counts, counts, counts. You know the next possible value. Here are examples of continuous. Things like your height. If I tell you I am 5.8 feet tall, okay, that's not 5 feet 8 inches, that's 5.8 feet. How tall is the next possible person? 5.9, or is it 5.81? Or is it 5.8001 feet? Like, depending on how granular you can have your measurement be, there's an infinite possible values, okay? So these are measurements. Time to run 500 meters, temperature outside. Measurement is continuous data. So we're running out of a little bit of time here. So on your own, here's eight data values or eight data examples to figure out on your own if it's continuous or discrete. I have the answers on the next slide. So I encourage you after class to just quickly check that out. Okay. I want to end class. We have just 10 minutes left talking about sampling methods. This is how you collect data. And there's a lot of different ways in the real world to collect data. So I just want to talk about some of the most important ways that data is collected. I'm not going to necessarily quiz you on this, but just when you read a study, understanding how the data, how they got it is important. All of these are statistically okay ways to collect data. All right, so there's 4 types of major sampling methods. There's simple random sampling, SRS. This is the most important. Then there's something called stratified sampling. There's something called cluster sampling. And there's something called systematic sampling. Okay, so simple random sampling is a procedure in which each member of the population is chosen strictly by chance. So every member can be picked, and if you're picked strictly by chance, and each member of the population is equally likely to be chosen. Okay, if you can do this, all right, this result is called a random sample. So this simple random sampling is the most important sampling method. Okay, this method, the simple random sampling, is the basis for advanced statistical theory. A lot of the theories I have in this class will say, if you have a simple random sample, you can conclude the following, okay? So the best way to visualize simple random sampling is it's like drawing names from a hat, okay? Everyone has the same chance of getting picked, okay? Another common way of sampling is what's called stratified sampling. So the stratified sampling is this. You take the population and you divide the population into non-overlapping groups, okay? So imagine you have this population here of 7 people. You're gonna put the first 4 people in one group, and then you're gonna put the, excuse me, this is a little bit of a typo here. You're gonna put 4 people in this group and 5 people in this group. So forgive me, imagine there's 8 people, or 9 people, excuse me, in the population. Sorry about that. So you're gonna have non-overlapping groups, okay? So you can take your population and split it up into non-overlapping groups. And then what you would do from every single group, you would sample a few people. So population into different groups. And then you sample a few people from each group. So that's one way to collect what would be called a stratified sample. Then there's something called a cluster sampling method. So what the cluster sample method is you take your population, imagine all these dots are different people, and you split your population into non-overlapping groups. So just like stratified, you take your population and you split into non-overlapping groups. And what we saw with the stratified sampling is what you did was you took a few people from each group. With cluster sampling, what you do instead is you say, I'm going to take all the people in this group and all the people in this group. And this group and this group will form my what's called cluster sample. Okay, sorry I'm going so quick on this final step. I just want to get this done before our class ends. Our final method is what's called systematic sampling. And a systematic sample is obtained by selecting every kth individual or object in a population. So it's like, imagine if you have all the people in your population lined up. Just drawing people, we'll give some people a smiley face here. A systematic sample would be like saying, hey, let's sample every other person in the population. So we'd sample this person, and this person. So just how it's done in a systematic way, and then all those people would form your systematic sample. All right, there's another visual here just so you can see the difference in how this is done. I'll leave this for you to review on your own. But what I want to end with in class is what's called errors in sampling, okay? And sometimes, this is why I love statistics so much, sometimes statistics or statistical inference leads to the wrong conclusion. And the reason you can get a wrong conclusion from data is because of one of two reasons. You can have what's called non-sampling errors, and you can have what's called sampling errors. So non-sampling errors are the result from the survey process and are due to non-responses of individuals. So if you're selected to be part of a survey and you don't respond, that creates a little bit of an error. Like this is something the government tries to control for with the census that's coming out. So did everybody here fill out their census, just out of curiosity? Well, let me ask you this. If you don't fill out your census, what happens? What does the government send to your house? I'm actually seeing them walking around my neighborhood. Yeah, they send a census ticker, so they try to control for this. Another issue could be inaccurate responses. This can cause errors. Like for example, if I'm selected to be part of a survey, and then, they say, we want to estimate how much money people make on average in the United States. And I say, I make $1 million a year. That would cause an error. Okay, I obviously don't make that much. A lot of other things, poorly worded questions so that you don't understand it. These can cause errors or form incorrect conclusions. The final thing is what's called sampling errors. So these are errors that result from using sampling to estimate information regarding a population. This type of error occurs because the sample that you collect gives incomplete or inaccurate information about a population. So let me give you an example of a sampling error. Suppose you want to estimate average income in the United States. Okay, and you're going to sample 30 people. The first 29 people that you sample have normal jobs, okay? Teachers, doctors, lawyers, bus drivers, nurses, things like that. But then the 30th person you call is Bill Gates. Okay, does Bill Gates make a lot of money? Or maybe even Mark Zuckerberg, someone like that, okay? If you were to take his income and sample it in or average it in with the other 29, you would get a value that makes no sense or is inaccurate when you wanted to estimate for the entire population. And these are reasons why I kind of love statistics, because sometimes even if you do everything right, you're gonna make the wrong conclusion. And generally in math that never happens, right? Like when you take algebra or calculus, there's always a right conclusion and a right answer. But sometimes in stats, no matter what, you can make an incorrect conclusion. Okay, whew, we made it. What did everyone think of their first online lecture?
Good.
I hope it's okay. Let me just thank you. I'm glad you enjoyed it. I enjoyed it too. Let me just say one last thing before we end here. So in class on Thursday, what I'm going to do is it's going to be a little bit more interactive, and we're going to do a lot more examples instead of me just shouting information at you. So please download the 2 PowerPoints. I know, I'm sorry, I did go over too fast. Download the PowerPoints and have them. What I will do right now is I'm going to post the lecture to Blackboard, and I'll send you an email with the link to the recording, and you can go back and you can listen to the lecture at your own pace. All right, everyone, I just want to end class just by saying thank you. I hope you had fun, and we will we'll see you on Thursday, and I will send the link for out on Thursday, and I'll see you in a couple days. Bye, everyone.
Thank you.